Okay. So let us start with first looking at the approach for finding min and max. So we have to find min and max element in an array in a most efficient possible way to find out. So we saw that in a brute force. So what happens in a brute force is we do 2n minus 2 comparisons, right? This is what we do in case of brute force, right? So we when we saw a pairwise method, so how many comparisons we were doing in a pairwise method? So in a pairwise method, we were doing totally 3n by 2 minus 2. This was the comparison. And you can see that this is far better than this. When n keeps on growing to a very large size, this always outperforms this method. So today what we're gonna do is we'll try to look into a approach which we can intuitively identify as divide and conquer. Okay, so as a quick recap, what we saw in divide and conquer is divide and conquer is an algorithm design method wherein we have a larger problem and we keep on splitting into half and half, and we keep on splitting into half and half, and then we find a solution for sub problems. So it could be a case that one of the solution for sub problems may be a solution of all entire problem, or you may need to combine the solution of all sub problems to get a solution to your larger problem. That's a divide and conquer. So we'll try to look into an approach which would be now what I would say is divide and conquer. And once we find that approach, we'll try to convert that into a Python code as well, right? So let us suppose if I have the following array, okay, and let me put some elements in that 2, 9, 3, 1, 0, and let's say I put 8 here, right? So if this is an array and I have this following elements 2, 9, 3, 1, 0, 8. So I want to find a min out of this. So let us look at the approach. What I say is we have to go for divide and conquer approach. So in a divide and conquer approach, what happens is we keep on dividing, right? So if I want to divide this array, one of the easiest way of dividing the array is to divide into half, right? So let us talk about this approach. Fine. So what we'll do is we have divided this into 2, 9, 3, and another part would be 1, 0, and 8. We know that if I have n is equal to 1, for example, if n is the size of array, if n is equal to 1, how many comparisons I need? 0 comparisons. So if n is equal to 2, how many comparisons I need? 1 comparison. So what is the least sub problem which I can easily solve? What is that least sub problem which I can easily solve? The least sub problem which I can easily solve is to divide the array till I reach to the n is equal to 1. Because the moment I get n is equal to 1, I can now be able to identify what is the min and what is the max of this array by looking into that. And once I get min and max for a subproblem of size 1, from this I can construct a subproblem solution for a subproblem of size 2, right? So let us do one thing. So is the 3 a subproblem which I want, which I can easily solve? As per my assumption, I want to divide this array till I get a subproblems of size 1. If subproblems of size 1, then I almost have a solution there, right? So then we have to think of how do I combine the solution I get for a one subproblem of size 1, right? So it's a size 3, it is still large for us. So what we're going to do is we're going to split it. So let us do divide by 2. So if I say it is index 0, index 1, index 2, index 3, index 4, and index 5. So if I do divide by 2, what I gonna get? So if you do length of array by 2, then length of array is 6. 6 by 2 is 3. So mid is 3, right? So we will always keep mid to the right, and we have divided it in this way, right? So if I do this, so here the index is 0. What the index is? 2. So if I do, for example, if I want to divide by 2, you have this approach of taking length by 2, or you can take start and end divided by 2. That's also a perfect way of dividing that. So what you do in this case? Start plus end. So you can call it as low and high, or you can call left and right. So easiest way to divide the array would be left index plus right index by 2. So what you get by when you do left index plus right index by 2? 0 plus 5 by 2. How much you get? 2, right? So this is the index where you will be splitting that. If I go on same logic, what would be the division of this two? 0 plus 2 by 2? 1, right? So 1 is this index. So you will be doing the split here. So I might not, I think this is intuitive. Like either you take this mid division to left or right, but while implementing that, you have to be very sure about that, so that you are not ignoring the mid element. Likewise, if you do 3, 4, and 5, so 5 plus 3, 8. So 8 by 2, 4. So here is where. So if you decide to split it by 8 here, so if you include left to mid and mid plus 1 to right, that's what we are doing. So how is our division? Left to mid and mid plus 1 to right. Are you getting? Are you getting the division boundary? What we are doing? So this is mid. So left to mid, and this would be mid plus 1. That's how we are dividing that array, right? So assume that we have divided this into these two forms. Now after dividing that, what are the two sub problems we are getting? One with 2 and 9, and other with 3. So do you divide this? What do you get? You get sub problem of 1 and 0, and another sub problem of 8. So is this the sub problem which we can solve? We have decided that I'm going to divide the array till I get a sub problem of size 1. So you will further divide it. What do you get? You get two sub problems, which is 2 and 9, and 3 remains as it is, and this gets 1 and 0. So 8 is still single, so 8 remains as it is. So now what we need to do is, I have divided this sub array into sub problem. What is this? This is sub problem 1, sub problem 2, sub problem 3, 4, 5, and 6, right? Now what I want to do is, when I divided sub problem of size individual 1, I have a solution to this sub problem. What is min and max? So let us denote the min and max by tuple min comma max. So let us denote this notation. So in a bracket, I will be denoting min comma max. So what is the min and max at this stage? Min and max is 2 comma 2. What is min and max at here? It is 9 comma 9. What is min and max at this point? 3 comma 3. What is min and max? Here it is 1 comma 1. What is min and max? Here it is 0 comma 0. What is min and max here? 8 comma 8. The same element is minimum and the same element is maximum. So you have divided this array into sub problems. Now you have a solution to sub problems. But what I want a solution to this larger problem, larger problem. So what I need to do is, I have divided. Now I need to conquer that. So now we are looking into a phase called as conquer phase. So in this conquer phase, is this a sub problem where solution of one sub problem, the solution of larger problem? Or is it a type of a problem where solution of all sub problem creates a solution to a larger problem? So is it the first approach, or the second approach. First approach, what I'm saying, solution of one sub problem is enough. In second approach, solution of all sub problems is needed. So in a chat window, type your answer, either one or two. What kind of problem it is? Yes, it is a second approach. So in a second approach, I have to merge all these solutions. So let us look at logic of how we are gonna merge it, right? So here I have 2 comma 2. So let me try to take some, okay, so I'm going to take this blacking, right? So now I need to merge. So when I'm merging this, when I'm at the very lowest level here, when I'm at the very lowest layer, I have two solutions, 2 and 2. So I need to merge this solution of this sub problem and this sub problem, and I need to find a solution for this upper sub problem. So it includes that, see, I have a min max. So here I need to find out what is min and max if I combine these two sub problems. So how many comparisons you require in order to find min and max at here? So this min you will be comparing with this min. So the minimum which you get at the left sub problem, you will compare with the minimum which you get at right sub problem. So what is minimum among these two? It is 2. You will compare the max of left sub problem with the max of right sub problem. What you get? 2 and 2, which is greater? 9. So here you get a solution. So here you have this. Likewise, when you do here, this 1 is compared with this 5. So what you're going to get here? 1. The max at this sub problem and max at this problem. What is max? 1. So max is this, min is 0. Sorry, I think I just meant it. So this min, and this min you're comparing. You're getting 0, 1. So now think of this. So now you have these two pairs to combine. Here you have these two pairs to combine. Are you getting? So now you talk about this two. So this minimum will be compared with this minimum. This max will be compared with this max. So compare this to what you get here, the minimum at this sub problem level. What do you get here? 2, 3. What is minimum? 2. And what is max? 9 and 3. What is max here? It is 9. Likewise, compare these two minimums. This and the one which you get at sub problem at this level, 8 and 8. What is minimum? Is 0 and max 1 and 8. What is max? 8. Now what is remaining? You have to merge these two solutions. What you get here? So 2 will be compared with 0. What is minimum? 0. And 9 will be compared with 8. So what is max between 9 and 8? 9. So is this the solution? So for array 2, 9, 3, 1, 0, 8. Is this the solution? Is 0 the minimum? Yes. Is 9 the maximum here? Yes. So am I getting a solution by divide and conquer? Okay, so just give me a quick feedback. Have you understood this approach of dividing this and merging the solutions? Okay, so others, raise your hand if you have understood that. Okay. Okay. So now that you have understood this approach, let us try to find out the complexity of this, right? So you have understood this. So now I want to find the time complexity of this approach. So earlier, in the, if I talk about what was that pairwise method, right? In a pairwise method, just by analyzing the working of algorithm, I was able to find the step count, right? So the method, the way we found the number of comparisons required for that our pairwise method, which is 3n by 2 minus 2, that was something we calculated by tracing that algorithm. We know algorithm, we said that we had a pairs. each pair executes n by 2 times, and for each pair I do 3 comparisons. So that's how we arrived at 3n by 2 minus 2. But now this is recursive one, right? If this is recursive one, it's very difficult to visualize. The problem with recursive approach is it is very difficult to visualize. Um, See, visualize these trace of steps. So the best method when it comes to recursion, and where you want to find the complexity of that approach, or to find out in how many comparisons it generally takes in terms of n, the best thing to do is to model it as a recurrence relation. So let us try to model as a recurrence relation. So when you want to model that as a recurrence relation, what is more important is to first find out the behavior of your algorithm. So what exactly happens for this algorithm, and what is that iterative step? I need to model that iterative step. So to model that iterative step, I'm going to analyze the working of our algorithm. What we saw that we have an array and we keep on dividing it, right? So this is subpart and this is subpart. Then we further divide this. So we get a two subparts, right? So assume that this is an array of 4 elements. So when you do the array of 4 elements, the first break was here, then the next break was here, and I got a size of n. So I got a sub problem size of n is equal to 1. Right. So now tell me, what I am doing is I am dividing that. So each iteration, for every iteration, what I am doing, I am dividing a larger problem into a sub problem. So if here is n is equal to 4 in the first iteration, in the second iteration, what has n become? N is equal to 2. In the third iteration, what has n become? N is equal to 1. Right. So how is it working? So in a divide phase, what we are dividing is, if I have a n, it becomes n by 2 after next iteration. Then further it becomes this by 2, so it becomes n by 4, right? I hope you're getting that division. So n by 2, n by 4, and that. Okay. And so in a division, it is division of that while conquering that. So this is something a divide. But what I am doing during the conquer phase. So in a conquer phase, I am merging this solution. So I need to find out how many instructions or how many steps I require to merge a solution. So for that, let us consider this left part for a quick use case. So I have a problem, larger problem. It is n by 2. You are working on half of n by 2. Then you do it and then you get n by 2. So how many comparisons you take to merge two sub problems? How many comparisons you are doing? So here what I said is, see, if n is equal to 1, if n is equal to 1, do I need any comparison to find min and max? No, if it's only one number, the same number is min and max. So 0 comparisons here, okay, to find min and max. But to find min and max at this parent level, what I am doing here? So the min max of this, so the pair of min max, so in order to find the solution of the at this parent level, how many comparisons I am doing? Can you guess? For a subproblem of size 1, 0 comparisons I can be able to tell. But whenever you're merging solutions of two subproblems, how many comparisons we were doing to arrive at the min and max at the parent level of that subproblem? So the merged problem. Yes. How many comparisons we are doing? We are doing two comparisons, right? What were those two comparisons? If I go back and if I talk you, so this is what, right? We get min max, min max. Compare these two minimums and compare these two max. So in a two comparisons, I'm getting the min and max at the merge subproblem. Are you getting this? So given this understanding, if I go further, I can model the recurrence relation. So the time taken by this algorithm to solve n will be equal to time required to solve the half part, one half part, plus another half part, maybe the right part, and two comparisons to merge these two half parts. Are you getting this? I hope you are getting that. So what is this? This is your left subpart. This represents your right subpart, and these are two comparisons required to merge the subproblems. So two subproblems which you created, these are the two comparisons required to solve these two merge two smaller problems. Understood this? So now that you understood, and remember here, if I take t of 1, if subproblem is of t of 1, how many comparisons you take here? 0. So effectively the t of 1 would be 0. If t is of size 2, how many instructions? One compare instruction is enough to solve a subproblem of size 2. Clear? Understood this? Let me know if you have understood this relation. Why I wrote t of n is equal to t of n by 2, n by 2. If you understood, just raise your hand. Okay, fine. So now let me continue this. So now that you understood, so how do we solve recurrence relation? By recursively substituting the values. So we call it a substitution method. What we do, we now put what is this t of n by 2 and what is this t of n by 2. So what, let us do one thing. So let us try to minimize that. We can write it as 2 twice t of n by 2 plus 2. So this 2 of n by 2, t of n by 2, what I did, it is 2 t of n by 2 plus 2, right? Now if I want to combine this t of n by 2, how do you write this? 2 in bracket plus 2. What are you going to write here? Replace this. What if I replace this n by n by 2? What I'm going to get? 2 t of, what I'm going to get? 2 t of n by 4 plus 2. So now if I merge all this, what I'm going to get? 4 t of n by 4, multiply this. So plus this 2 plus whatever the multiplication you get by 2 and 2. What you are getting? 4. So 4 t n by 4 plus 2 plus 4. Solve it further. What you going to get? If you further substitute this, so 4 plus 2 plus 4, t of n by 4. T of n by 4 would be 2 t of n by 8 plus 2. Solve this, what you're going to get? 8 t of n by 8 plus 2 plus 4 plus multiplication of this 4 with 2. What you are getting? 8. So now, can you write it in a general equation? Can I generalize it? So can I generalize it like t to the power of n by is equal to, can I generalize this? See this term, 8, 8, 2, 4, 8. Can you generalize this? If my assumption that n is equal to 2 to the power of k, if I assume n is equal to 2 to the power of k, if I can represent the n as an uh, of this format, 2 to the power of k, what will be this? Can you guess? Can any quickly guess? If I want to just take it further. Can you take it further? So what you can do at the max is, see, as I said, n is equal to 2 to the power of k. I need to substitute n is equal to 2 to the power of k. If I now see, this is always our assumption whenever you solve recurrence relation, especially in this binary context, n is always equal to 2 to the power of k. But here we have some issue. So if I submit n is equal to 2 to the power of k, uh, then if I take this, what happens is t of n is equal to, I can do that. So I can write it as 2 to the power of k multiplied by t by n to the power of 2 to the power of k plus, how do you write these terms? How do you write to these terms? These are k, and if k could be from 0 to, it can be in any value. So the k varies from any two values. So it could be plus, this 2 plus 4 plus 8 can be taken as summation of 2 to the power of I, where I is equal to 1, right? 2 to the power of means 1. It is 2 to the power of 2, 2 to the power of 3. So I is equal to 1 to k. This is what I can do that for any k. But the problem with this, what is the problem with this? The problem with this is, if I substitute n is equal to 2k, if I substitute n is equal to 2k here, if I substitute n is equal to 2k here, what happens? 2k by 2k, what it becomes? It becomes t of 1. But t of 1 is 0, right? So we will not go to that level. So we will not go to that level. So in our assumption, in our assumption, we would max go to t of k minus 1. So we will not go to k, but we will go max to the k minus 1. Because if I make 2 is equal to k, then 2k by 2k is equal to t of 1, t of 1 is equal to 0. So what I want is, I want to be always at a n is equal to 2 to the power of k minus 1, not till k. Are you getting this? If I go with this assumption, so what I'm saying, n is equal to 2 to the power of k minus 1. So I will max take the n to the 2 to the power of k minus 1. If it's the case, then t of n, can I write t of n? T of n is equal to 2 to the power of k minus 1, right? So then 2 to the power of k minus 1. Now you plus the summation, right? What was that summation? 2 to the power of I, and where I is equal to 1 to k minus 1. Max it will go to k minus 1. Now 2 to the power of k, remember it is being multiplied with t of, right? So what was that? T of n by 2 to the power of k minus 1. Okay. So how do you solve this? Solve it. So 2 to the power of k minus 1 multiplied by, what is this t of n? Now if I take 2 to the power of k minus 1, what is this k minus 1? So k, 2 to the power of k minus 1, can I write it as 2 to the power of k by 2 to the power of 1? That's what I am writing that. So 2 power of k minus 1 can be written as 2 to the power of k by 2 to the power of 1. So when you take this to the top, it becomes k minus 1. So going on that, what it would be? T of n by 2 to the power of k by 2 plus summation of 2 to the power of I is equal to 0 to k minus 1. So solve this further, what happens? It becomes 2 to the power of k minus 1. What happens with this? What happens with this? So 2 to the power of k, so now it becomes n, right? It becomes t of n by 2 to the power of k multiplied by 2. So change of denominator. So n means n is equal to 2 to the power of k, 2 to the power it goes off, right? Then what we have is we only have 2. Then this term. So the overall equation can be written as 2 to the power of k minus 1 multiplied by t to the t of 2 plus summation of 2 to the power of I, where I is equal to 1 to k minus 1. So t of 2, what is t of 2? How many comparisons are required when t is equal to 2? 1, right? So now when you do it, I get k minus 1 plus this summation. So now what is this summation? If you look at this summation, what is this summation? This summation is nothing but it's the summation of that values like 2 plus 4 plus 8 plus 16 plus so on, right? This was this summation. What we will do is we will try to do this. So 2 to the power of k minus 1 plus take 1 2 outside. If I take 2 outside, what will it be? 1 plus 2 plus 4 plus 8 so on. Now what is this? What is this? 1 plus 2 plus 8. Now when I go further with this, it is a series. It is a series of geometric progression. I hope you know what is arithmetic progression and geometric progression. So arithmetic progression, it's an addition. For each term, there is some addition. In a geometric progression, for each next term, it is multiplied by one ratio factor, right? So it is 1, 2, 2 to the 4, 4 to the 8, 8 to the 16. So it's a geometric progression. Remember, I'm not going to go deep into mathematics, but whenever I have this series, wherever I have this series, where it is always multiplied by 1 plus 2 plus 4 plus 8, if you solve it by geometric progression, and in geometric progression, we have sum at n. Like what is sum at n? So in a geometric progression, by using the formula for sum of n terms in a geometric progression, here it is given as, so I'll directly solve. So k minus 1 plus 2 into, and whenever you take by applying the sum of nth term in geometric progression by applying this formula, later you can go through and you can find out that formula it fits. So here what we get is multiplied by, we get a term like 2 to the power of, uh, go through any standard geometric terms, you will always get. So it would be 2 to the power of k minus 1 and minus 1. How did I come to this term? This is by applying a formula of geometric progression, sum of n terms in a geometric progression. So going further, what I get? So t of n is equal to 2 to the power of k minus 1 plus 2 multiplied by 2 to the power of k minus 1 minus 1. Solve it. After solving it, what you get? What do you get? So can anyone attempt to solve this? Okay. So now if you solve this, what you'll get? 2 to the power of k minus 1. 2 multiplied. 2 multiply means this minus 1 goes off. The minus 1 means 2. So you get 2 to the power of k minus 2. Multiply this 2 inside this. What do you get? So you get 2 to the power of k plus 2 to the power of k minus 1 minus 2. After solving it further, solve it further. What do you get? If our assumption was 2 to the power of k is equal to n, right? What I said is that so I said n is equal to 2 to the power of k in general, but since if I make this as it is, I'm going to get t of n by 1 is 1. So what I said here, we will not go to this level, but we will go to k minus 1 limit. But still our assumption that n is equal to 2 to the power of k still holds. Just we are not going to that, so our limit is k minus 1. So if you take 2 to the power, it is n, and what would be this? It would be n by 2, because 2 to the power of k minus 1 can be divided as this. So n minus 2, 2. What do you get? Solve this. So 2n, multiply this, 2n. So it is 2n plus n by 2 minus 2. What do you get? This will finally give you a relation that it is 3n by 2 minus 2. This is what you get. Take a bigger notation. What you get it after putting a bigger notation? This constant term goes off, internal this goes off, this constant goes off, then it becomes O of n. But in general, the number of comparison for this recursive code is also 3 of n by 2 minus 2. Okay. So final comparison, brute force, what I'm getting? 2n minus 2. Pairwise method, what I'm getting? 3n by 2 minus 2. And this divide and conquer. And this method is also called as tournament method. I hope you're getting that. So two, we have group A, group B, 4. I think the way we get to final, right? From quarterfinals, semi-finals, and finals. So this approach looks like that. So people also call it as tournament method. So after working recurrence relation, the complexity is even 3n minus 2. Which is better? Is this or this? In your terms, which is better? Though these two are exactly same, what would you prefer? So which approach you think as a developer you should prefer? If assume that if n is arbitrarily large, like n is equal to 1 lakh element, 2 lakh elements, for that, which approach you think could give us better performance? Can you type your answer? What should be your solution? 1, 2, or 3? Assume that we wrote a program for all these three approaches. What approach you gonna prefer in general? As a developer, what approach you gonna prefer? 1, 2, or 3? Okay. Others, please type. I want your responses. Okay, scroll down. Anyone with I think 1, 2, 3, 3, 3. What others? What others would want to go for? What 3? Onkar, yeah, Onkar Nora says 2. Okay, so since you have said 2 something odd, can you tell me why only 2 and why not 3? Mhm. Yeah, let me tell you. I would prefer, if you ask me my experience, and if you ask me to do, or most of developers who are well versed with language implementations and working of programming language and runtime, they will always prefer 2. Why? Because 2 is an iterative one, 3 is a recursive. Even if these comparisons are 3 and by 2, there is always a overhead in implementing the recursion. I hope you are getting that. So whenever we go further, and whenever we implement recursive ones, as long as file is small, that is fine. But when n size is arbitrarily large, there is a lot of recursion overhead, and in a systems where which do not have much of memory and all that, it becomes a big headache. So shall we write a program for this? I think we have 10 minutes. I think 10 minutes is enough to write a program for this. Okay, so let us write the program for this, and then we can. Okay, let me know. Do you see the screen?
Yes, sir.
Okay, so let us quickly write our program. So to write our program, what is the first thing we need? We need to write a recursive function. So this is a recursion, right? So I need to write a recursive function. So in a recursive function, I need to take care of the whatever the sub problem, the base case, the merging of solutions, and divide of solutions, and returning the solution. Once we are done with that, I think we are fine to solve that. Okay. So the first thing is, this is our iterative program, right? So what I will do is, I will first take this from there as it is. So this is our list, and we will still import random and time, because I want you to work on an arbitrarily large array. So import time. Okay. What, since I want to define, first is define the method. So let us call min max. Then how do you want? So since this is a recursion, let us keep providing this. So for this, what we will do is we'll first provide the numbers. So we have to provide the array, and once we provide the array, what we're going to do is we will also provide left and right. We will rely on that concept of left and right. Fine. So this num list will provide as it is, num underscore list, and we will provide one left and right index. So based on that, it will keep on going that. So whenever we enter this, I need to first always take care of base case. What is the base case for this recursion? Can anyone tell me? So if you think of the division operation, what was the step wherein the division operation stopped? So that indicates the base case where your recursive thing will stop. What was that? N by 2, n by 2, n by 2, n by 2. Where did I stop further dividing the n by 2? I stopped at a point where n was 1. So how do you know n was 1? You have to compare. If you find left is equal to right, means left and right is same, it means that I have reached n is equal to 1. So base case is n is equal to 1. So you have to stop at that point. So if you encounter that, what you're gonna get? So I'm gonna say, let us take something called as min, and I think let's call min now. I think min is something. So min num will be num list of left. The minimum will be 1, and max num will be same. If n is equal to 1, both are same. So min and right both are gonna same. And what I'm gonna do is define the method. What this will do is this will return a tuple. I hope you know what are Python tuples. Tuples are a value where I can return a pair. So tuple itself is one entity. So whenever I return, say a comma b in Python, it always gets returned as a tuple. So return a tuple of min and max. That's what I want to return this. So this function at any point of time, it will return that tuple. So what I'm going to do is return the min number and the max number if n is equal to 1. And what is other one? If I'll also take the other case. If left problem is size of 2, right? If problem is size of 2, I'll merge that. So whenever I get a whenever I get a problem of size 2, I need to merge the solution based on the solutions of individual sub problem of size 1. So if f left is equal to right plus 1, so if this is the case, what I'm going to do, if this is a case, what should I do? I think it's a equality sign. Left is equal to right plus 1. Always better to keep them in bracket. So if this is the case, what you will be doing? So in this case, min number is equal to, what will be 1? What would be this one? See, in Python, I think I can always go for in C, C++, and Java, you have ternary operator, right? In Python too, we have a ternary operator. Let me teach you that. So what I'm going to do is num list of left is less than num list of right. If this condition is true, if it is, then you will return num list, or else so I hope you can still rely on are you was this taught to you, ternary operator in Python? Was it taught to you? Can you give a very quick feedback? So it is quite intuitive, I'll tell you. So this is written as this. If this is that, if this condition matches this, then what we do, we directly write like condition, some value is written, a value is written if the expression is true. If it is not, I need to return another expression. So value if, else what it goes to that. So what we do is return. So this is how you return it. Return num list of left if this is less, else num list of right. How is it read? This will be returned if condition is true, else this will be returned to this. So I'm deliberately going this so that you can also learn the Python syntax as well. So what should I do for max? You will return num list. I think this exactly goes as it is. I need not do anything. The num list of left if is greater, else right. And I think I'll make this as max num. Max number is equal to num list of left. So if num is greater, this condition is true, then this value is assigned to this variable. If this is false, then this value is assigned. So this is called as ternary operator in Python. So later on you can go through this ternary operator in Python. I hope since you said this basic syntax was covered, I'm just using that. Okay, so this is done, right? We have written what is if n is equal to 1, and this is what we are writing, what if n equal to 2. Now, what is remaining further? If n is beyond greater than 2, what I need to do is I need to do divide operation. How do I do that? If it is that, if the subproblem size is greater than 2, I need to divide that. So to divide that, what I'm going to do? So divide that and call the function as it is, right? First divide and call the function as it is. So here if. So this is for when subproblem size is greater than 2. If it is a case, we need to divide that. So what we will do is we'll call the method as it is. So we will call the same method. What is the recursive method? Min max, pass the num list, and here what will be the new thing? What will be the new thing? So what we will do is when I enter here, I have left and right, right? So I need to create two halves. So the first thing is left half. So left half call will be num list from left to mid. What is mid? Left plus right by 2. Remember, if you want a quotient and remainder one, you have to do double slash. If you do single slash, it will go into floating point operation. Then what is remaining? Right half is remaining. So right half, what will be the call? We have seen that. What will be right half? Left plus right. So it is mid plus 1, right? What I said, it is mid plus 1. So put a bracket here, a proper bracket, mid plus 1 to right. This becomes right half. Okay. So this function will give you some value. So min left half, comma, max right half. Okay. No, it will get min left and max left. So let us call it as min L, max L. So this will give you that call. What this will give you? This will give you min right, comma, max right is equal to. Remember, in Python, this always takes the tuple. So what you are returning is you are returning a tuple. This tuple is assigned to this values. So this is actually a tuple. So function, when it returns a tuple, the first member of tuple takes into this, second member of the tuple goes into this value. Okay. So now you have these two. What you need to remain is merge operation. So that is conquer. Right. So in this conquer operation, what you're going to do is here you have to merge them. So the what is the final then? So min final is equal to, I need to compare this both, right? Compare this both, and whichever is greater, return that. So you will do min L if min L is less than min R, else it would be min R. So I'm using ternary. So you will return left minimum will be minimum if left minimum is less than that. Okay. Then max final is equal to max left if max left is greater than max from right, else it would be max R. So min F, max F. And in the end, what are the pair which you have done? You have to just return that. Return as a tuple. So min final and max final. That's it. So now let me execute this on this. So let us see what output we're going to. So we are done with that. So we are going to make a final method call. We're going to make a method call here. So how do you get that? So print min max, pass the num list, and what is the left index? 0. What is right index? What is the right index? Length of num list -1. I think we are just passing the index, right? Okay. So let us execute this. So if I execute this, I should now get the result. Okay, shall we run this? Run. Recursive min max. Okay, did I get this -1099? -1099. So let me change this array. Can we make something? Instead of minus 10, I'll make it as 10, and here I'll make it as 100. So what should be the value in this case? 0, 4, 6, 7, 10, 2, 8, and 9, 10. What would be the answer in this case if I execute this? 0 and 100. Okay. So I hope you understood this logic, how we wrote this. Okay. So let me know if you have understood. I'll stop.